Welcome to Lesson 9, Naming and Formula Writing for Tertiary Compounds. Our lesson objectives: identify tertiary compounds containing polyatomic ions by name, and construct chemical formulas for tertiary compounds containing polyatomic ions. When compounds have more than two elements, it contains a polyatomic ion, which we can find on Table E in our reference table. Polyatomic ions are a group of two or more atoms that are very strongly bonded together, and they act as one unit or ion. And they will bond with other ions to form compounds. So here's an example of a polyatomic ion, NO3, which is the nitrate ion. So the N and the O's are strongly bonded together, and this whole unit here carries a charge. So this whole thing is an ion. It has a -1 charge. So let's look at how do we name tertiary compounds. We're going to follow the same rules as we did for naming binary compounds, except that the polyatomic ions on Table E are named according to the table. So for example, NaNO3, Na is sodium, so we'd write out the full name sodium. NO3, Table E tells me it's nitrate, so I just use that name here. So this is sodium nitrate. Let's see some more examples. CaCO3, so first and foremost I'll look at it and see that it has more than two capital letters, so it's not a binary compound, it's a tertiary compound. And I'm going to name the first element, calcium, in its entirety, and then I locate CO3 on Table E, that's my polyatomic ion, and I write the name that's present there, and it says carbonate. This is calcium carbonate. The next one, Li, I write lithium, I locate ClO2 on the reference table, Table E, and I see that it says chlorite, so this is lithium chlorite. Next one, Na is sodium. I look up OH. OH says hydroxide, so this is sodium hydroxide. The next one here we have two polyatomic ions put together, and we can do that, they're both ions. And so we're going to look the first one up, which is NH4, and that's going to be ammonium, so I write ammonium. And then PO4, I look that up, and that says phosphate, so this compound has a name, ammonium phosphate. Let's check your understanding. Can you identify tertiary compounds containing polyatomic ions by name? So now let's look at how do we write formulas containing polyatomic ions. Well, it's going to be the same as what we did for the binary compounds. A couple key things. Remember that we never changed the subscripts for polyatomic ions. They are locked up. And when we're writing a chemical formula, if there is more than one of the polyatomic ions, we're going to put parentheses around it, followed by the subscript for the number of those polyatomic ions used. Let's see an example. We want to write the formula for ammonium chloride. So the first thing you do is look up the symbols. So ammonium I find on Table E. Now how do you know it's on Table E? Well, for the most part, if it's not an element name or doesn't end in "ide," we know then it's probably a Table E ion. But most common endings are going to be "ates" and "ites" on here. There are a few "ides," but not many. So for the most part, it's "ates" and "ites." But you can always just kind of cruise Table E and just make sure that the substance they're talking about is not listed there. So ammonium I find here. It's NH4+1. I write that here. Chloride is chlorine. This is the second element, so the charge must be negative, so it's a -1. And then +1 - 1, this is going to balance out. This is going to equal 0. And so it's just going to be one of these ions and one of these ions. So it's NH4Cl. Let's see another example. Let's write the formula for lithium carbonate. So again, I'm going to write the chemical formulas here. So Li, lithium, is a +1 charge from the reference table. And then carbonate, I locate carbonate, which is here, and it's CO3 - 2. So I put that there. So if this is a -2 charge here, and this is +1, I'm going to need two lithiums, two +1 charges, to balance out the two negative charges of the carbonate. And so when I write my chemical formula, I'm going to put two lithiums and one carbonate. So two lithiums and one carbonate. Don't be confused that this 3 means I have 3 of these things. This 3 is part of the polyatomic ion here. Let's look at another example. Write the formula for calcium phosphate. So I look up calcium on the reference table, and I see calcium is a +2 charge, so I write Ca +2. And then I look up phosphate on table E. Here's phosphate. It's a PO4 -3, and I put that here. And so I have a +2 charge and a -3 charge. And in order for that to balance out and equal 0, I would need 3 of the +2 charges and 2 of the -3 charges. And so that means I need 3 calcium and 2 phosphates. And so I'd write that Ca3, 3 calcium indicated here. That gives me a +6 charge. And then to show that we have 2 of this phosphate, 2 of this polyatomic ion, I put the ion in parentheses and then put the 2 outside the parentheses, indicating I have 2 of this entire unit here, 2 of this PO4 ion. So let's check your understanding. Can you construct chemical formulas for tertiary compounds containing polyatomic ions? At this point, you should be able to identify tertiary compounds containing polyatomic ions by name and construct chemical formulas for tertiary compounds containing polyatomic ions.